talks about corresponding angles, alternate interior angles, alternate exterior angles, and corresponding same side interior angles. Okay? Well, there's some special theorems that go along with these types of angles. Okay? The first one is the corresponding angle postulate. Postulate is something that doesn't really require a lot of work to be true. You kind of look at it and be like, yeah, can't argue with that. That's true. Okay? And that's saying that if parallel lines are cut by a transversal, then each pair of corresponding angles are blank. And you maybe got to this in the practice yesterday, where you kind of figured this out. Does anyone know corresponding angles? They are, yes. So if you think corresponding angles means they're sitting in the same corner. So if they're sitting in the same corner, what do we know about them? They're what? If they're sitting in the same corner, are they going to be the same or different? Same, okay? And we can say, fancy word for same in geometry is congruent. If corresponding angles are congruent, yeah, they're sitting in the same corner. Obviously, they're going to be the same. So who can give me an example in this diagram? We talked about these yesterday. We know N and M are parallel from yesterday. I know these guys are parallel. Put my arrows on it. Who can give me a pair of corresponding angles? Huh?
7 and 2.
7 and 2. 7 and 2, they're both sitting in that upper right corner. 7 and 2 are corresponding angles. That means 7 and 2 are congruent. 7 and 2 are congruent. Alright. Alternate interior angles theorem. If two parallel lines are cut by a transversal, then each pair of alternate interior angles are, any guesses? What do we think? No guesses? They're also congruent. Alternate interior angles are also congruent. So who can give me a pair of alternate interior angles from this diagram? 3, 5 and 2. Good. They're both inside. They're in between those parallel lines, opposite of each other. 5 and 2. So that means 5 and 2 are congruent. What do we think about alternate exterior angles? If alternate interior angles are congruent, what do we know about alternate exterior angles? They're also going to be what? Congruent. They are also congruent. Okay? Who can give me a pair of alternate exterior angles? Yesterday. Alternate. Okay. Perfect. 6 and 4. They're both outside those parallel lines and opposite of each other. So, guess what? Those are also congruent. Angle 6 is congruent to angle 6. Those are alternate exterior angles. They're the same. Congruent. Same side interior angles. Says if two parallel lines are cut by a transversal, then each pair of same side interior angles are not congruent. Don't write that. They are not congruent. Any guesses on what same side interior angles might be? What? Different. They are different, but there's something special about them. Any guesses? They add to something. They add to 180. What's that fancy word for meaning adding to 180? Supplementary. I also like to write it as sup. And write it the whole word and just write sup with double P. No, you're talking about supplementary. Okay. So who can give me a pair of same side interior angles? Give me a pair, Ross?
5 and 1.
5 and 1. Both inside those parallel lines on the same side of that transversal. 5 and 1. So we can say the measure of angle 5 plus the measure of angle 1 is equal to 180 because they are supplementary. and the same side interior angles. Okay? So why are these certain angles congruent? Okay? Someone just didn't sit down and be like, you know what, I think they are, so therefore they are congruent, and everyone's going to believe me. Okay? No. Someone had to sit down, do some math to show why these angles are congruent every single time. Okay? And here's the math that they did. Okay? It says why are alternate interior angles congruent? Well, we can use that corresponding angle postulate. Again, that's something that's just automatically true. You don't have to think about it. Just oh yeah, duh, that makes sense. That's true. Okay? We can use that to help us see in the diagram above why alternate interior angles are true or congruent every time. So in this diagram above, right here, the upper right corner, we know n is parallel to m, and we want to show that angle 2 is congruent to angle 5. We want to show why those are congruent to each other. Well, when you first look at the diagram, I'm trying to show that 2 is congruent to 5. So I have to start with one of those angles. Okay? We're going to start with 2. And I noticed in the diagram that 2 is congruent to blank because vertical angles are congruent. Looking at that diagram, what angle is vertical to 2? What are we going to put in that blank? 3? 3. Okay? We know angle 2 and angle 3 are congruent because vertical angles are congruent. Okay? So we linked 2 to angle 3. Well, I also noticed when looking at that diagram that 3 is congruent to 5. Okay? Angle 3 is congruent to angle 5 because blank angles are congruent. Well, if we take a look, what's the relationship between angle 3 and angle 5? What kind of angles are those? Corresponding. They're sitting in the same corner. We know corresponding angles are congruent. Again, you can put CORR. I'm going to write it out so you know what I'm talking about. Corresponding angles. And there's this thing in math, right, where if one thing's congruent to another, and another thing's congruent to that same thing, then the first and second thing are congruent. Meaning, okay, 2 is congruent to 3. We also said that 5 is congruent to 3. So then, if they equal the same thing, don't they equal each other? Like if x was equal to 5 and y equals 5, aren't x and y equal to each other as well? Equal the same thing? Yeah, that's true in math. Well, that's what we just did here. 2 and 5 both equal the same thing. They're congruent to the same thing. So that means 2 and 5 also have to be congruent to each other. So essentially what this person did was realize, oh, these 2 angles, they're congruent to the same angle. That's what they did. They noticed that 2 and 3 were congruent because they're vertical. They also noticed, well, 5 is also congruent to 3 because it's corresponding. Well, they're congruent to the same angle, so they have to be congruent to each other. That's what they noticed. And they, again, probably didn't have numbers like this and stuff like that, but just of how they discovered this. Same thing can kind of be done to show, well, why are corresponding angles congruent? Right? Well, if we take a look, again, we know those lines are parallel in the diagram. And we want to show that the corresponding angles 4 and 8 are congruent. Okay, well, when we look at the diagram, we know angle 4 is congruent to blank because vertical angles are congruent. Well, what angle is vertical to 4? Look at the diagram. Brief. 1. 1 and 4 are congruent to each other because they're vertical. That's what we can fill in there. Okay. We also know that angle 1 and angle 8 are congruent because blank angles are congruent. Well, what kind of angles are 1 and 8? They're alternate interior. Alternate, abbreviate. interior. We know from here that alternate interior angles are congruent. Well, just like the last one. Well, 4 is congruent to 1, and 8 is congruent to 1. They're congruent to the same thing. So that must mean they're congruent to each other. They're also the same. So that's how they figured that one out. They figured, well, they're obviously congruent to the same thing. So, what happened to my congruency? What's there? Oh, my work list. That's an accident. That means they're congruent to each other. And that's how they discovered that. They just noticed that 2 angles were congruent to the same thing. Therefore, they have to be congruent to each other. Okay? Questions on that? Okay, this is just helpful. This is very informal reasoning of why these things work way, way, way down the road. We will go into more formal reasoning of why these things work. This just helps you get a better understanding. Okay? Or later on down the road. Well, now we can apply this. So in the diagram below, lines N and M are parallel. And angle H is equal to 116. So I'm going to label in my diagram. I'm going to mark it right there. We want to find the measures of the missing angles. When I have a problem like this, I like to figure out, well, which angles are congruent to my given one. So look at that diagram. Which angle is also congruent to angle 8? 3? Give me 1. 6. How is 6 congruent to 8? They're vertical. Very good. So if 8 is 116, I know 6 is going to be 116. Okay, what's another congruent angle? It can be congruent to 6. It can be congruent to 8. Chris? 4. How is 4 116 degrees? What's it congruent to? You have multiple right answers. What angle is 4 congruent to? 6. Why is it congruent to 6? They're alternate what? They're alternate series. Okay. You also could have said 4 is congruent to 8 because they're corresponding. Both are right. Both get you the right answer. Plus 1. 1. How is a 1 congruent? Or how is 1 116 degrees?
Oh, because it's vertical to 6.
Yeah, it's vertical to 6. Good. You also could have said it's alternate interior to 8. It's also corresponding to, vertical to 4, corresponding to 6. Okay. We have 6, we have 4. Which one am I missing? 1. Okay. Cover up my numbers, then I don't know what I'm telling you. Okay? So now we have to figure out the other ones, because there's no other angles looking on there. We covered alternate interior, alternate exterior, corresponding, we covered vertical. There's no other angles on there that are 116 degrees. How can we find the other ones, Chris? Good. Why are you subtracting 180?
Each one is 5, and 2, and 4 is 8.
Good. 2 and 4 equal 180 because they're what kind of angles? You said 2 and what equal 180?
2 and 4 is
Because they're what type of angles? Sounds like a line. They're linear. And we know linear pair angles add to 180. So we would just do 180 minus 116. What do we get when we do 180 minus 116? 64. Well, what other angles are 64? 3 because it's vertical to 2. What else? 5 because it's corresponding to 3. What else? 7 because it's vertical to 5. Okay. You also could have noticed that these were same side interior angles. You maybe noticed that those were a linear pair. You could have also noticed that those are same side and you're still subtracting them from 180. Okay, it's just however your brain looks at the picture. Sometimes you might do a totally different path than your neighbor and you still get the right answer. But sometimes there's more than one way to get the right answer in geometry. Okay. Questions over that? Due to time, we're skipping that one. Same kind of concept. You just have multiple parallel lines. We can go over that one tomorrow if we need to. Let's take a look at these. So the following sets of lines are parallel. Find the value of x. So again, we have to figure out How am I going to set up an equation to find x? In order to set up an equation to find x, you have to figure out, well, what type of angles are these? So we look at our diagram. What type of angles are 3x minus 26 and 2x? Very good. They're alternate interior. They're inside and opposite of each other. What do we know about alternate interior angles? They're equal. They are the same. So that's how we're going to set up our problem. We're just going to set them equal. Alternate interior angles, always set them equal. And then solve. When we solve, this is a little different. You got to move the big number over. Can't move the little number over. We won't have anything on that side. Or you make more work for yourself. So we get negative x is equal to negative 26. What do we have to do to get rid of that negative? Divide, because technically it's a negative 1. 2 minus 3 is negative 1. And then negative 26 divided by negative 1 is positive 26. We all know how to solve. That was we take a look at B. What kind of angles are 7x plus 1 and 4x plus 3? Same side as here, good. They are on the same side of the transversal, but they're not on the same point. That's okay. Corresponding, I think, are tricky to recognize. I think they're the hardest ones to recognize. They are same side interior. They're on the same side of the transversal. They're both inside the parallel line. What do we know about same side interior angles? Harder? They equal 180. So that's how you're going to set up this problem to solve. You just add the two angles together. Set them equal to 180. Recognize the angle relationship. Use that info. What you know about those angles to set up your problem. What's our first step when solving this? Good. When we do so, we get 11x plus 4. What's our next step? What's our next step? Minus 4. 11x equals 176. And then divide by 11. We divide by 11. What do we get? Questions over that. So I'm going to show you a really cool trick with multiplying by 11. You totally trick your friends out. You know how to multiply by 11 in your head. So let's say we multiply like 13 times 11. Okay. All you have to do is break up the number and then add. 1 plus 3 is what? 4. 43. Works like a charm. So you do like 19 times 11. What would 19 times 11 be? Break it up. Oh no, that's a bad one. That's a bad one. Go to the next one. Do 18. I have to double check 19. Do 18 using that trick. 198. Break up the digits. Add them for the middle. So when you divide, when you divide a big 3-digit number by that by 11, now it's 16. So like 17 times 11 would be what? Ah. So you go to your friends like, tell me what 13 times 11 is, or ask me. Like that, drop it half. I don't know, I love multiplying by 11. I think that's really cool. Sit down, try to figure out different numbers, multiply by 11. I just blew your minds, didn't I? So you're looking at me like, whoa. Yeah. That's cool, I think. There's little cool things about it. But I love multiplying by 11. I don't know if it works for every two-digit. I know it works from 11 to 18. Have to double check 19. 1,000 what? 1,000. 109. That? Yeah, that works. Because 19, you multiply by 11, you break it up in half. Okay, I just had to double check that. It might work for 20. Not sure. What is it? For 20? Let's see if it works for 20. 209? For 20? 220? We'll figure out later. So yeah, that's fine. It'll work. You just learned a new math trick that I think is totally fascinating. Alright, if we take a look at example 4, what's a little bit different about this one from the other ones? Yeah, there's two sets of parallel lines and they're each acting as their transversal. Okay, what else do we notice that's different? Another variable in there. There's an x and there's a y. Okay? Well, which one do we clearly have to solve for first? X, because y. Yeah, there's two of them. There's no other y there. There's no other number you can pair with y. There's only x's. So we have to deal with x first. Sometimes you can get away with solving for y first or second. But in this situation, we have to solve for x. We don't really have any other option. To figure out how we're solving, you have to figure out which sets of parallel lines our x is dealing with. I notice that the top x, 2x minus 10, is sitting on this red parallel line, or this green one I just highlighted, and x plus 15 is sitting on that line. I notice they're both touching this blue transversal right here. So these green lines are acting as our parallel line. This blue line's acting as our transversal. If it's helpful, take your hand or another piece of paper, cover it up. Because we're only dealing with this section right there, this left side. We're ignoring the other half of it. So just looking here, what kind of angles are 2x minus 10 and x plus 15? What? Very good. They're both sitting in this bottom left corner. What do we know about corresponding angles? They're the same. So we can just go ahead and set them equal. Because they are equal. They're the same. And then you just solve it like a normal equation. Move the x over. Add 10. And x ends up equaling what? 25. Okay. Well, that's x. Okay? For y, we have to figure out, well, which one of these angles are we going to pair up with y? Alright, we have to pair one of them up. When we look at this diagram, again, we have to figure out which one has the same transversal, which one's touching the same line as y. Okay, so I'm going to highlight the lines that y is sitting on. Y is sitting on this line, that yellow line, and this green line. Which of the x's, x plus 15 or 2x minus 10, is touching one of the same lines? 2x minus 10. We can't do anything with the x plus 15 because it's not touching a line that y is also touching. It's going to float out there in no man's land. Okay? So we can't do anything with it. So we can ignore this bottom half. Okay, you can cover up with a paper, whatever you can if it's helpful. But those two yellow lines are our parallel lines, this green lines are transversal. And again, that's helpful, cover it up. What kind of angles are 2x minus 10 and 4 times y minus 25? Alternate exterior. What do we know about alternate exterior angles? They're the same, right? But can we set y equal to x? No. So what do we have to do to get rid of that x? Plug in. Take 25. Plug it in for x right here. Then you can set it equal. Okay, so when we take 25 and plug it in for x, 50 minus 10 is 40. Good. So this angle now is 40. Now we can set them equal. So we're going to say 4 times y minus 25 is equal to 40. And then solve. What do we have to do to solve? Yeah, just got to distribute that 4. We do so, we get 4y minus 100 equals 40, and then solve it like a normal equation. Move the 100 over. We get 140. Divide by 4, and y equals what? 35. And we are done. So sometimes you have more than one variable in a problem. A little more tricky with parallel lines. Okay?